Okay, my dear student, today I am going to explain about the Kirchhoff current law. Kirchhoff current law or Kirchhoff junction law. Write down the amount of current, the amount of current, the amount of current entering a node, is equal to amount of current leaving the node is equal to amount of current leaving the node and next point right now, next point, it is based on the law of conservation of charge. It is based on the law of conservation of charge. This is very important line. Please highlight this. It is based on the law of conservation of charge, and first thing, the amount of current entering a node is equal to amount of current leaving a node. First thing, what is the node? Node means when three or more than three wire meet at point, that point known as node. For example, like this, wire 1, wire 2, like this. This is known as node. This is a node point. More than three wire meeting at point known as node. Suppose in this node, coming current I am assuming I1 is toward this, entering current toward the node I2 and I3, and outgoing current is I4. Then we can say that what I4 is equal to I1 plus I2 plus I3. Means current entering a node is equal to current leaving the node. Node means what? When three or more than three wire meet at a point, and that point known as node. Okay, when the current entering a node, look at this, I1, I2 and I3, these current entering the node, and I4 is outgoing the node. Then I4 nothing but I1 plus I2 plus I3. Okay, similarly also we can say that like charge, current nothing but rate of flow of the charge, means what? Rate of incoming charge toward the node is equal to rate of outgoing charge toward the node, and there is this node point, there is no accumulation of charge. That's why whatever charge is coming toward the node per second, and that charge leaving the node per second. That's why this law is based on the conservation of charge only. Okay, current is nothing but rate of flow of the charge. The rate of flow of charge incoming toward the node and rate of charge outgoing toward the node, and that is based on the conservation of charge. And also we can say that for example, when two or more than three pipe able to meet at this point, that point known as what? Junction point, where the pipeline more than three pipe meet at point, that point known as junction point. For example, whatever the flow rate of water, that A1 B1 coming with the velocity A1 B1, area of the pipe A1. This also coming with the velocity A2, area is A2, velocity is B2. Then water is coming toward the junction is what? A1 B1, that is the Q1. Q1 means mass flow rate of water, rate of flow of water. This is Q1 and this is Q2 and this is the Q3. Means the discharge. Able to get what? A3 V3 means rate of coming of water per second is what? Volume flow rate of water is coming toward the junction is what? Q1, and this is the Q2. Volume flow rate toward the junction is Q2, Q1. Then volume leaving the junction is Q3. This is another point. From this we can say that what? A1 B1 is equal to A1 B1 plus A2 B2 is equal to A3 B3, and this in the fluid mechanics, this part we can do. And there is no mass flow rate, and there is nothing mass accumulated at the junction point where all the pipe meet that point, and that point on a junction point, no much mass accumulate here. Mass will not accumulate at the junction point, and that's why we can use A1 B1 is equal to A2 B2 A3. The similar concept here also, when in the wire current will flow, means rate of flow of charge. Here water will flow or any liquid will flow, that rate of flow of liquid coming toward the junction is equal to leaving toward the junction, because junction is what? All three pipe meeting at point that known as junction. Here all more than three wire meeting at that point that known as node. Node and junction both are same things. That's why Kirchhoff law, current law, we can say that what? Kirchhoff junction law also. Okay. Now I will take one example. Wait, can I erase this? Now. Simple electrical circuit and given here. This voltage of this battery is given 10 volt and connected with the wire having resistance 2 ohm, and this also connected with the battery having voltage 2 volt, and this another wire connected to this, and this wire resistance given 4 ohm. I am writing this is the R1 resistance, this is the R2 resistance. Now first look at this circuit proper. Identify how many node point in the circuit. In this circuit, if I look at this circuit, here this is the point where the three wire meeting at this point, and that point known as what? Node point. And this point also 3 point meeting at point 3 wire, that also become node. Suppose I am given the node A, this is given name A, and I am given name this B. Now look at this. Potential I am assuming what? This side potential of the battery 0. Then what is the potential here? 10 volt. Because the difference able to become 10. And this is the connecting wire. This is the connecting wire. Then this is the difference is 0 only. Then able to get what? Potential at the node able to get 10 volt. Similarly, this is the 0. Then this point also 0 volt. And this point also 0 volt. Because this is the connecting wire. That's why potential drop is 0, and this point also becomes 0. If this point of the negative terminal of the battery becomes 0, then this side become this point potential become 2 volt. That difference must be equal to 2 volt of battery. Then now look at this resistance 2 ohm. This potential here become 10 volt only. This point potential 10 volt. And other end of this R2 resistance potential is 2 volt. Then the current will flow from high potential to low potential. Then how much current will flow in R2 resistance? Current in R2 resistance is equal to potential drop here 10 minus 2 divided by resistance is 2. Then we are able to get what? 8 by 2 able to get 4 ampere. 4 ampere. Now look at this resistance here. Current will flow. Suppose here IR2 IR1 current will flow here. Then current will flow in R1 resistance, that is what IR1 is equal to what the potential drop across this resistor 10 volt and this 0. Then we can write 10 minus 0 upon 4. Then able to get 2.5 ampere. 2.5 ampere. Now current in the wire, current in the resistance R1 is this direction, that is what IR1, that is 2.5. Current in this wire, this resistance IR2 resistance able to get this direction, R2 resistance current in this direction, that is able to get 4 ampere. Now look at the node A. This is the node point A. In node A, one current is going like this. That current is what? 2.5. And the current this side going to what? 4 ampere only. Then other point, this is a node A. This is a node A. Then this is the what? This is the another wire. Then look at this. These two current leaving from the node A. Then incoming current, how much able to get this? This is what? Sum of these two. Then 2.5 plus 4 able to get 6.5. 6.5. Then similarly for node number B, if you want to write node number B, you can draw. Node B, whatever current R1 going like this, IR1 able to flow like this also. And this side able to get what? IR2 also. Then node 2, node B, the current coming like this. This side current coming what? IR1, that is nothing but 2.5 ampere. And this side current coming what? IR2, that is 4 ampere. Now this line able to get how much current? Upside, that is summation of these two, able to get again 6.5 ampere. Means I am completed all the branches of this. In this branches of this circuit, its current is what? 4 ampere. In this branch, able to get current is 4 ampere, here 2.5. Now look at this battery number 2 volt. In battery 2 volt, current entered as positive terminal of the battery, means this battery is not a source of energy. This battery we have as a what? Consumer of energy, means this battery is the charging condition. Now look at this battery, and this branch able to get current is what? 6.5. And that current leaving from the positive node of this positive terminal of this battery, then this battery behave like is what? This battery is a discharging condition. This battery is what? Charging condition. And this able to consume energy. This is a consumer of energy. This is a supplier of energy. Then by junction law, we can write the junctions law or Kirchhoff current law. We able to solve this circuit, and that's all. Next topic we'll discuss Kirchhoff loop law in next class, and we'll discuss some questions also.